Howdy, I'm Audrey Smith, and today I will be presenting royal jelly proteins and their nutritional role in queen development and Apis mellifera. So this project will basically explore proteins in royal jelly, how they shape development of queen bees, and why royal jelly is a nutritional substance. So before diving in, let's look at a little background. All honeybees are genetically identical, but what determines their caste, whether they become a worker bee or a queen bee, is their diet. So queen destined larvae are fed specific exclusive royal jelly, which is produced by the nurse bees from their hypopharyngeal glands. Royal jelly is very protein rich, especially in a group called major royal jelly proteins, or MRJP. These proteins make up most of the protein content in royal jelly and are basically key to queen development. So ultimately, nutrition is basically what triggers the pathway to a queen. So my research question is, what specific proteins in royal jelly make it nutritionally crucial for queen bee development? This led me to examine 1, how royal jelly affects the larva survival and growth, 2, which proteins are most important, and 3, how the protein influences queen traits. First, let's take a look at how royal jelly affects basic development. This table shows larva and adult weights. You can see that the larva-fed royal jelly had a significantly higher survival and a greater weight gain compared to the larvae that were fed artificial diets. The adult bees that were developed from royal jelly-fed larvae were heavier overall. So even at the basic level, royal jelly is a superior nutritional resource, as it supports better growth, stronger development than in a substance diet used in this study. So let's take a look at proteins inside royal jelly. NJRPs 1 through 9 make up about 90% of protein content in royal jelly. So here this figure shows the gene cluster where NJRPs are located, and it shows that they belong in the yellow gene family, which is linked to insect development and communication. These proteins are nutritionally dense, as I said before, but are not just food. They also act as signaling molecules, which ultimately help guide the larva toward queen development, which is key. One of the most important MRJPs are MRJP1, also known as royalactin. Research has showed that it activates the EGFR pathway in its growth and development, or it's a signaling pathway, and this is activated. When it's activated, the larva develops queen traits and such as increased size, faster growth, the ability to reproduce. But when it's blocked, these queen characteristics do not develop, therefore they do not become a bee, even if the larva is still fed royal jelly. So again, MRJP1 acts as a molecular trigger for queen development, and it's ultimately leads to queen differentiation. Okay, so the figure here shows where MRJPs come from. The heat map shows MRJP 1 through 9 and the expression in different honeybee castes. You can see that the nurse bee heads have the highest expression, shown in the bright yellow at the bottom over the head label, and And this makes sense because nurses are the only ones producing the royal jelly. And in comparison to the queens and drones, as you can see, and also foragers, which are mostly dark colors, meaning they are very low in the MRGP expression. So basically, they are mainly produced, or ultimately, they are mainly produced by nurse bees, and their expression is concentrated in their hypopharyngeal glands used to make the royal jelly, and they support immunity, not just nutrition. Okay, so to summarize, royal jelly's unique nutritional value comes from high MRGP protein content. These proteins are rorolactin, especially rorolactin, are influence directly. They directly influence the larva growth and cast phenotype. So experiments consistently show that its proteins affect survival, their weight gain, and also queen specific traits. So overall, we see that diet acts as a molecular switch that controls queen development. The significance of this research, it helps us understand how nutrition shapes development of Aphis mellifera. It also has practical importance. I think that MRJP research can improve queen rearing, colony health, and basically our understanding of how insects regulate reproduction. I think future work should focus on isolating the functions of an individual MRJP or improving the artificial diets by mimicking these proteins. So here are my references. Thank you so much for listening and have a great day.